So we need to find the velocity and the acceleration. Right? We have the path and the height is given as 100. Can we find the distance travel in the horizontal direction at this particular instant? Right? Yes, we can. So apply y is 100, 0, 1, x squared, and you can get x from this equation. How much? What's the answer?
10 to the power 2.5.
Huh? How much? 100.
10 to the power 5 or 2.5.
10 to the power 2.5. Okay, you didn't get it into decimal, right? Fine. So let's keep it as it is. Maybe we will not need it. And then the question says, the plane rise with the constant velocity of 10 meters per second. What's that mean? It rising with constant velocity of 10 meters per second. What is that? Is it the velocity of the aircraft, or is it only the amount it moves upward? What is this 10 meters per second? Is it v dot, or no, the velocity v, or is it y dot, the vertical component? What do you think? It says rising, that means it is the vertical component. So y dot is given as 10 meters per second. So this is all what we get from this question. To find velocity, what we're going to do, we have the path y equals 0.001 x squared. We can differentiate this, right? Once you differentiate with respect to time, what will you get? Y dot 0.001 into 2x into x dot, right? From this, we do have values for this one, right? Because we found it from here. X is 10 to the power 2.5 or 100 into root 10. So that value we have. So we have y dot equals and from the question itself, y dot is given. So y dot we have it as 10. Now simplify this and find the value of x dot. And the next step, you need to find the acceleration. So we have y dot and x dot, that is all we have as the velocity component. What about the acceleration? How are we going to do that one?
Differentiate the horizontal velocity and the vertical velocity with
You can't do it separately, but you can differentiate this equation again with respect to time. Right? If you differentiate this one, it is not going to work because this is a particular instant when the plane is at this point. Right? You always have to differentiate the general equation. So if we differentiate this one, y dot is here we have y double dot x dot times x dot plus x time x double dot, right? So from this one, y dot is a constant, so this part will be how much?
0.
0, and everything else you already know. Okay, let's move to the next one. Question number 4. What about the next question? And how are you going to do this?
Get the value of centripetal acceleration and the tangential acceleration, then square it.
Then
Skull.
what kind of coordinate system that you are going to use? Cartesian or polar? Remember last time I show you how to do the curvilinear coordinates, where we have unit vectors along theta and r direction. Are we going to use that one or are we going to use ijk? Which one you think will be suitable for this case?
IJK.
Huh?
IJK.
You can do it with ijk because the curve is circle, but it will be much easy if you use the e theta and er coordinates or the curvilinear coordinates. So in this case it is the polar coordinates, right? Try this one with polar coordinates. You'll see that it is really simple equations that you will get. Can you remember what is the velocity? So the first one is position, r, how we define that? R into er hat, remember? And the velocity is what? What is the velocity in er and e theta coordinates? No one can remember. What is the velocity in this coordinate system? When you differentiate this, we get r dot er. That is fine. And what's the next part? Plus how much? R theta e theta, remember? And then the acceleration, what will happen? This one is bit long. You have r double dot minus r theta dot squared in the direction of er, which is the radial direction, plus r theta double dot plus 2r dot theta dot in the direction of e theta or the tangential direction. Remember this one? This is the general case. Now we can simplify this to our situation. Right? In our case, the position vector is 40 into er, or the radius is a constant. Right? When the radius is a constant, what that mean when it comes to the velocity? What will happen here? There is no r dot component, or there is no velocity along the er direction. Is that correct? It is obvious, right? Because this is going to move in a constant radius path on a circle. So there cannot be any radial velocity. So this is 0 and you have r theta in e theta direction. R is given right. And the magnitude of this one is given. From that you can find the angle. Once you have that, then we can use it in the next one to find the acceleration. Can you try this one? Take few minutes and try the remaining to find the acceleration of this ball. So the magnitude of this one is given 0.4 t squared. So this should be equal to r theta. And r we know already. That means 0.4 t squared is equal to 40 theta. From here you can get an expression for theta with time. Once you have that, do the required differentiations and get the acceleration. That's all what you need to do. How much is theta? Forty divided by 0.4, it is 100, right? No, 0.4 divided by 40, which will be 0.01 t squared. So the angle theta is 0.01 t squared. After that, again, when you look at the acceleration for this case, anything with r dot terms or r double dot terms will not be there because we have a constant radius motion. So this one will not be in our case, as well as this part. So the acceleration is really minus r theta dot squared in er direction plus r theta double dot in e theta direction. The question says find the magnitude. So get square root of r theta dot squared, the first term, plus r theta double dot squared. Any questions? You may able to do this with Cartesian coordinate, but the formulation will be much difficult than this one. Any questions? If no questions, let's go to the next one. Okay, fifth one is very easy one. You need to write down the equations for the projectile, right? You are going to throw something at v naught velocity. It is a vector under the action of gravity. So you need to find the vector r. Better to write it in vector form, having the unit vectors in x direction as I and in y direction as j. I think you have already studied about this, but if you let's do it in vector form. In that case, we will start with the acceleration acting on the particle and integrate twice to get the distance, right? So here the motion of the particle is governed by the equation, acceleration is minus g, and what is the direction? In j, right? This is all you have as the governing equation for the particle. Then what we need to do, we have acceleration. To get the velocity, we'll have to do what? You need to integrate it with respect to time. So let's do the integration. Integrate acceleration with time and do the same in the other side. When you do this side we have v, and here what will you get? Minus gt in j direction plus, as usual, you need the constant. But remember, this time the constant is a vector. Now, how we can find this vector constant? From the question, it is given that at t equals 0, we have v at 0, which is v naught y plus v naught x. So I wrote it in the wrong way. This is j, this is I, you have to write it in the proper side, right? V naught x in I direction plus v naught j y in j direction. So apply it here. T is 0, so this one is not there. So you get C as V naught x I plus V naught y j. So the velocity is V naught x I plus V naught y minus gt j. To get the distance, we need to integrate it once again with time. You have to integrate the whole thing, and in this case again you will get a constant, and we know that at t equals 0 the constant, let's say C2, again a vector, this will be how much? X naught I plus Y naught J. And then write the full expression for the acceleration of the particle. Any questions on that question? Anyone who is find it difficult? Remaining questions we will do on next session, because some things I have to teach you to do them. Let's open tutorial number 2 and try question number 5, which is this one. Question number 5. Can you try it on your own? So in this question, velocity of a particle is given in ijk components, and it start at origin. So we need to find particle's acceleration when time is 2 seconds, and also we need to find the position of the particle. To get the acceleration, what you need to do? You need to differentiate the given equation with respect to time. And that's all what you really need to do in that question. The position, not the velocity, is given as 16 t squared I plus 4t cube j plus 5t plus 2k, right? The acceleration is d over dt of v. So first differentiate the whole expression with respect to time. You will get 32t I plus 8 is t cube, right? Not 2. That means 3 into 4, 12 t squared j plus 5k. And then at t equals 2, just apply that value. A at t equals 2. So this will be 64i. 4 into 12 is 48j plus 5k. Next one, you need to find the position. To find the position, what we have to do is, so let's say R, we need to integrate V with respect to t. So this is the integration, and here it has given that at start the particle is at origin. That means whatever the constant will be 0. Finished? Any difficulties? If you done with that, start question number 6 on the same tune. Now the figure shows a mechanism with the link and two pins in two slots. Can you see? There are two pins at A and B, and there is a link which can move, right? The path of the pins are given by this equation, which is an ellipse, right? This is not b, it is y squared. So x squared over 4 plus y squared is equal to 1. That is the path. So when the link moves, what will happen? The two pins are going to trace the path or the slot which is an in the shape of a ellipse, and it asks you to find the velocity and acceleration of the top pin when the distance it travels in x direction is exactly 1 meter. Can you try this out? It is similar to the question we did with the aircraft climbing previously. So take few minutes and try this. So question number 6, path x squared over 4 plus y squared is equal to 1. We need velocity and the acceleration. So there is only one thing that we can do. What is that? We are going to differentiate this one with respect to time. So differentiate with respect to time. When you do that, what will happen? 1 over 4 2x into x dot plus 2y into y dot is equal to 0, right? We can do some simplification. Half x into x dot plus 2y into y dot is 0. Any question up to here? Okay, then what we going to do? We need one particular moment, magnitude of velocity at x equals to 1. So we have x equal 1 as our interesting point. So if x equals 1, from here we can find the value of y. How much is that? 1 over 4 equals plus y squared is equal to 1. That means y squared is 3 over 4, right? So y is root 3 over 2. So we have y. Then apply what all the known things into our differentiated equation. And there is one more detail. The question gives you that link moves with the constant speed of 10 meters per second. So it is shown in the figure. So that motion is only in the x direction. So if the link moves at that speed, the peg or the pin must moving at that speed in the x direction. So what it literally means is that the x component of the velocity x dot is 10 meters per second, right? Because that is the velocity of the link. So that one is also given. Then the only unknown of the time differentiated path is the y dot. So we can get half x is 1, x dot is 10 plus 2 times y is root 3 over 2 and y dot, which is the unknown. So this is 5. Root 3 y dot is equals to minus 5. Y dot is minus 5 over root 3. Now we have the velocity x dot as 10 and y dot as minus 5 over root 3. Then differentiate again with respect to time. When we do that, half x into x double dot plus half x dot squared plus 2 y into y double dot plus 2 y dot squared. Again, in here, the horizontal velocity x dot is a constant. If x dot is a constant, that means x double dot is 0. So this part is going to go out. You are going to end up with half x dot squared plus 2 y double dot plus 2y dot squared. Right, the only unknown in this one is y double dot when x is equal to 1 meter. So shall we wind up the session? Do you have any questions or anything that you need to ask? regarding today's work or before or something from your textbook, whatever it is, you can ask. And remember, as I told earlier, we will not be able to conduct the practical sessions this coming week. For the Cat 1 examinations, you have to go through the first book, Unit 1. Typically, that is how the cats are given. Cat 1 is from the first book and Cat 2 is from the second book. And the next thing is that